Welcome everyone. In this video, I'm going to go through 5 A-level chemistry multiple choice questions. The questions are from the 2017 AQA Paper 3 and cover cisplatin, the Boltzmann distribution, polymers, moles and oxidation state. Let's get started. Here's the first question. Cisplatin is an anti-cancer drug. Which structure represents a stereoisomer of cisplatin? It is good exam technique to reject the impossible answers first. NH2 is not a ligand. The answer cannot be option C or option D. In option B, the NH3 and Cl- ligands are on opposite sides, so option B is the trans isomer. In option A, the NH3 and Cl- ligands are adjacent. Option A is the cis isomer. So the correct answer is option B. Here's the next question. The diagram shows the Maxwell-Boltzmann distribution of molecular energies in a gas at two different temperatures. Which letter represents the most probable energy of the molecules at the higher temperature? You should be very familiar with the shape of the Boltzmann distribution and the axes. The x-axis represents energy, the y-axis is number of molecules with a particular energy. The distribution of energies at a lower temperature is highlighted in yellow. The most common energy is at the crest of the distribution. A represents the number of molecules with the most common energy at the lower temperature. B represents the number of molecules with the most common energy at the higher temperature. C represents the most probable energy of molecules at the lower temperature. And D represents the most probable energy of molecules at the higher temperature. Relating this knowledge to the question, the answer is option D. Here's the next question. V2O5 can be used as a catalyst in the contact process. Which is a step in the contact process in which the vanadium is oxidized? First of all, we can assign oxidation states to vanadium. Oxygen bonded to another element usually has an oxidation state of -2. The sum of the oxidation states in a species is equal to the overall charge in that species. So in option A, vanadium is reduced from an oxidation state of +5 to +4. In option D, vanadium is reduced again from an oxidation state of +5 to +4. So the answer cannot be A or D. Option B and C both show vanadium being oxidized from +4 to +5. Two steps in the contact process are shown in red on the right hand side. This knowledge is required in order to answer the question. Note that some sources represent 2VO2 as V2O4. Relating this knowledge to the question, the answer is option C. Next, we have a question on polymerization. This structure shows a section of a polymer chain formed from the random polymerization of two different monomers. Which pair of monomers could produce this polymer? Each of the options, A to D, shows a pair of alkenes. So this question is specifically about addition polymerization. Let's look at each option in turn. First of all, if we take the monomer in option A, CH2CHF, I have drawn a red dotted rectangle around the sections of the polymer that could come from the monomer CH2CHF. Next, I have drawn a blue rectangle around the sections of the polymer that could come from the other monomer CH2CHCF3. We can see that all sections of the polymer have been accounted for, but let's check the other options. A red rectangle has been drawn around the sections of the polymer that could come from the monomer CH2CH2. A blue rectangle has been drawn around the sections of the polymer that could come from the other monomer CHF-CHCF3. We can see that certain sections of the polymer cannot be accounted for. One of these is highlighted in yellow. Now let's look at option C. In a similar way, I have drawn a red rectangle around the sections of the polymer that could come from the first monomer in C, CH2CH2. And now blue rectangles around the sections of the polymer that could be accounted for from the other monomer, and once again we can see that there are sections of the polymer that cannot be accounted for. Next, option D, red rectangles have been drawn around the sections of the polymer that could come from the CH2CHF monomer. The other monomer in option D does not appear anywhere in the polymer. So the correct answer is option A. The red and blue rectangles represent how the monomers relate to the polymer structure. Next we have a moles question. I have purposefully taken away the options A, B, C and D. It's always a good idea to calculate the answer without the options in mind when you're doing multiple choice questions like this. The equation for the reaction between zinc and hydrochloric acid is zinc plus 2HCl gives zinc chloride plus H2. What is the minimum mass in milligrams of zinc, which has a relative atomic mass of 65.4, needed to react with 50.0 centimeters cubed of 1.68 mole per decimeter cubed hydrochloric acid? First, we can work out the amount of hydrochloric acid in moles using amount is equal to concentration multiplied by volume. We must convert the 50 centimeters cubed to decimeters cubed by dividing by 1000 or using times 10 to the minus 3. The amount of hydrochloric acid works out to be 8.40 times 10 to the minus 2 mole. From the balance equation, 1 mole of zinc reacts with 2 moles of hydrochloric acid. It is a 1 to 2 reaction, so the amount of zinc in moles is equal to the amount of hydrochloric acid divided by 2. This works out to be 4.20 times 10 to the minus 2 moles. The mass of zinc in grams is given by mass is equal to amount in moles multiplied by molar mass. The molar mass of zinc is equivalent to its relative atomic mass and is given in the question. Substituting these numbers into the equation gives a mass of zinc of 2.7468 grams. We must convert to milligrams by multiplying by 1000, which is equal to 2.75 times 10 to the 3 milligrams. If we compare this value to those given in the question, we can see that the correct option is C, 2.75 times 10 to the 3. If that's helped, watch this next video and subscribe for more chemistry explained, and check out the website www.flipchem.com. Any questions or topic requests, just post any comments. Take care and good luck with your studies.